Assalamualaikum and hi. This video is for assignment control system fundamental BEEA2383. My name is Muhammad AIMAN bin Muhammad AZAM with my partner NURSHAHIRAH binti Abdul JALIL represent for this video. For the model we use the room heater. Room heater are the portable heater that used for heat a small space. Heater usually from the gas or the electric. Room heater are used for the elder, ill and the crippled person. Room heater can adjust by the temperature and duration for suit the space that we want to heat. Alright, for the room heater, we use a second order system. Second order system is the lowest system that is capable for producing an oscillator response in the response to the step input. The spring mass damper system and the electronic RLC circuit are two examples of typical configuration. Second order system that have a ability to exhibit oscillatory response call for the alternation of the two distinct and separate form of the energy storage. Some examples of this form include the inductor and the capacitor found in RLC filter, as well as spring and stationary mass. Okay, we go to the simulation part. The first picture that we saw is the closed loop for the room heater. Input for the room heater is desired temperature, and the controller for the room heater closed loop is the thermostat controller, and it will go to the furnace full valve and go to home heater process, that is the process or the plant plant. For the closed loop room heater, the feedback is temperature sensor and the or transmit. The output for the room heater is the temperature that we want. Alright, for the simulation software, we use a Skylab for do the simulation. Alright, the first component that we use is step function. Step function will connect the positive summation. Simulation will connect to the controller. Controller will connect to oscilloscope, and oscilloscope to connect to clock. The negative summation will connect to between the controller and oscilloscope. For transfer function that we use for this block diagram is 0.3 over 0.78 square plus 0.8223s plus 1. After complete the block diagram and input the transfer function, we run the system. Alright, this is the result of the transfer function that we do before this. We get the undampered system for that transfer function, and that means it's an undampered system for the room heater. We can see the room heater will go to the heat, the high heat, and it will decrease until we get the temperature that we want. Okay, that is the result. The peak value of the temperature that we get from the graph is 30.1166, and the final value that we want for the heat temperature room is 24.231. After that, we must plot the lower limit and upper limit from the graph. After we plot the lower limit and the upper limit, we will get the TS. TS is the same line for the upper limit and the lower limit. Alright, that's all from me. Then the presentation will continue by my partner. Thank you.
Hi, Assalamualaikum. My name is NURSHAHIRAH binti Abdul Jalil and my matrix number is B0820100383. So for today's video, I'm going to present my part for this assignment group. My task is to do the calculations, discussion, analysis and conclusion. Based on the graph, we obtain the peak value, peak time and final value for this calculation. I then use the formula provided to calculate the zeta and obtain 0.4111. I use the formula to calculate the peak time, which was 3.45 seconds. The time setting value is 9.73 seconds and the overshoot is 24%. We ran a simulation on this project and were able to obtain the results. The block diagram for this design is a closed loop system. A closed loop control system is a mechanical or electronic device that regulates a system automatically to maintain a desired state or set point without human intervention. We faced several challenges while completing this assignment, one of which was creating the block diagram. To obtain a beautiful graph and a logical value, we must find the appropriate value for the transfer function. It is quite satisfying when we achieve the same value in terms of calculation and graph. We use a closed-loop block diagram in a second-order system for this room heater. The response of a second-order system is more complicated as compared to first-order system, whereas the step response of a first-order system could be fully defined by a time constant determined by pole of transfer function and initial and final values. The step response of a second-order system is in general much more complex. In view of the proof introduced, I can say that this venture is fruitful. In spite of the fact that there might be a few sections that were noticeably flawed, however, we are fulfilled in light of the fact that we have put forth a valiant effort. An easily overlooked details about this undertaking is room heaters are portable or wall-mounted heaters that are used to heat a small space. The majority of room heaters are powered by gas or electricity. Room heaters are useful appliances that provide focused and localized heat, which is ideal in a room for people who are elderly, ill or have limited mobility. Moreover, I might want to underscore that we want to comprehend what has been realized, particularly during the lab session. Scilab application is extremely useful to set up this task. Thus, it has observed that Scilab has the ability to visualize data required in numerical computation. Scilab is very useful for performing numerical operations as elaborated in this paper. Many projects can be developed using Scilab. Scilab can also be utilized for image enhancement, numerical enhancement, and signal processing. Thank you.